Mm, My name is Joshua Virhanga, together with my colleague Ndambaka. We are here to present a theme, model agnostic models for millennium prediction. We are focusing on federated future, federated futures, continuous learning, for medical imaging, processing with federated future, augmentation. His excuse me a bit, I have some later in case someone did not come out clearly. So next I'll go straight to the problem statement. Traditional machine learning normally depends on extensive centrally collected data. This normally creates privacy risks because sensitive data from different sources must be aggregated into a central repository. This raises concerns over privacy and government concerns. So federated learning addresses these issues by allowing distributed systems such as health centers to collaborate between machine learning models, result sharing sensitive local data. However, also decentralized this approach introduces its own set of challenges. This includes non-independent and identically distributed data. This negatively impacts the convergence and performance of models trained via standard federated learning. Additional hospitals possess limited data sets. This is because of high cost of annotation and limited expertise, and in addition to that, it is due to logistical barriers within rural areas. So this hinders the effective application of conventional deep learning methods. So in order to address these challenges, future learning emerges as a promising techniques which enables rapid model adaptation using only limited numbers of reproducible samples. So traditional related models do suffer from catastrophic forgetting, whereby models is previously knowledge of policy with the new ones. Policy with the new training data. So this phenomenon is especially decrementals within evolving domains such as medical imaging, where new disease manifests, diagnostic methods keep on changing and imaging techniques also arise. To ensure sustained effectiveness and the models, federated models must incorporate continuous learning mechanisms that enable incremental knowledge accumulation without getting previous acquired knowledge. So in addition to standard federated learning, which normally overlook the potential benefits of federated feature augmentation, this enhances the robustness and performance of models by getting feature representation from different components without breaching that confidentiality. So the main challenge this research is addressing is developing and implementing a unified federated framework that effectively combines federated learning, feature learning, federated augmentation, and continuous learning. The major goal is to have a robust model performance while maintaining patient privacy and allowing efficient learning from limited and evolving datasets. So the major objective we are designing a PVCP Raving Predator Learning Framework for malaria image analysis, which shall integrate features learning methods that allow rapid local adaptation within minimum data samples. We shall also implement continuous learning for the model updates without the loss of previous knowledge acquired. So the novel aspect of this solution is we're integrating fish. There is the fish dot learning with continuous learning and fish augmentations. So we are eliminating the need of central servers to collect for data collection by complying with data regulations. There's also incremental adaptation, which demonstrates how continuous learning ensures systems remain up to date with a relevant conductor. So this is the architecture of the system. So from here, these are the participating the health centers or the hospital. So each hospital will train each model on their local data sets, and they will only send model updates to the server. So these are the performance metrics. Server receives these performance metrics, aggregates them. After aggregating them, it will form a global model, which is sent back to the client. So the client will use this model to do their respective prediction. So this is our architecture of the system. So here we have the hospitals. This is the federated framework, which does the aggregations of the different metrics set by the different hospitals. So the final model is optimized and compressed to ensure that it can. And after it has been compressed, this is deployed on edge devices. These edge devices are used by the local clinics to do malaria detections. So these devices send back the feedback in form of metrics, the prediction of trends for continuous model improvement. So we also did data exploratory using flashy contrastment, as you can see that the affected cells and their texture is a bit disorganized. This enables the clinician to know which samples are affected and which ones are not. And from this, you can see that the normal cells are very okay. Their textures is well uniformly distributed. What are the impact on the relevance to Uganda? In terms of Uganda, malaria is prevalent in Uganda. Uganda is one of the most lenient countries with high burden of malaria, which remains a leading cause of morbidity and mortality. This is according to the World Health Organization. So any efforts that is geared towards eliminating malaria will be benefits to the country. So Uganda as a country also lacks infrastructures. We do have very limited infrastructures within the country. We have very limited trained personnel who are able to do carry out the diagnosis of malaria and most especially within the local settings. So by introduction, the AI tool that will enable the locals to detect malaria, this will be very of help to the locals. So PVC concerns. So the major goals of our solution is the models each clinics will be able to train their data local, and the owner send the mobile app address to the central server. So this maintains privacy. And the global malaria is also a global challenge. This is majorly, particularly in sub-Saharan Africa, South Asia, and other parts of Latin America. So SDG alignment, our solution aligns well to the SDGs 3, 10, and 16. So we are targeting health care providers, the hospital clinics and health centers within the country. We are also present in rural areas. We are also targeting pharmaceutical companies, intellectual properties and innovation. We are providing a privacy preserving federated learning framework that will interpret few learning, federated documentation, continuous learning. Monetization, we shall provide software services that will enable healthcare and researchers to integrate into the existing system without sending to train the models. Not needing to train the model themselves, this will be offered on demand where users will pay for the computational resources they consume. So in brief, this is the overview of our solution. Thank you for listening to me. I welcome questions and answers. Thank you.